Hi, today we're looking at exponential functions, in particular how to graph application problems and how to use a table to help solve. So we're using Desmos for today's lesson. In this first example, the population of deer near a town is estimated to increase by 19% each year. And the deer population today is 15,000. So we created a equation here in Desmos. 15,000 is my initial value times a quantity of 1.19, which is the 1 plus the 19% rate. And then that's to the power of x. So I created a table and it generated these values. So we can see, right, when x is 0, year 0, my initial value is 15,000. And then the next year it increased 19% of that. So 19% of 15,000 and then added back to the 15,000 gives me the 17,850. So that's year 1. And we continue seeing that year 2. And so then I can look and answer other questions like, what will be the population in year 5? What will be the population in year 10? And so on. So this is a growth example because the growth rate of 19% is added. So it becomes 1 plus r. And so since this growth factor is greater than 1, then the graph is going to increase. Now let's look at an example where it's decreasing. Turn that off. So now in this example, we have the cost of a new car is $32,000. Then it depreciates or loses value at a rate of 15% each year. So each year, 15% from that original value and from the previous year. So I use the equation 32,000 as my initial value times. Now in this case, I'm going to subtract 15% or 0.15 from 1. So it's the same thing as doing 0.85 is the same thing as 1 minus 0.15. It's the same thing. You notice if I put it back, you get the same exact numbers here as if I do here. So you can express it either way. I'm actually going to leave it just because it's shorter as 0.85. You can do it either way. And then that's to the power of x. So I'm going to graph it. So this means when x is 0, my initial value of my car is 32,000. So these values actually over here really don't make sense for this problem. If I really wanted to, I could actually get rid of them because I know I'm not going to have anything before that. So I can actually use these curly brackets if I want to say x has to be greater than or equal to 0. And that would actually be a little more realistic and get rid of those negative values that really don't make sense for this problem. From there, it's going to decrease. So I'm going to take 15% of 32 and then subtract that from that original 32,000. And so for that first year, I'm going to be down at 27,200. And then 15% of that and subtract it from the 27,200. And that gives me this next value. So I can do that for different years and continue my table. Just adding it each year, 5, 6, 7, 8. And I can see these values here on the graph as well. So in 10 years, it'd be just a little over $6,000. All right, that's it. Just a nice way to model your exponential values. Good luck, and we'll see you next time.